Okay, we have here another problem related to odd and even functions, and we're asked to decompose cosecant of x times cotangent of x. And I have this formula here for odd even decomposition, which is going to allow us to take any function and break it into its odd and even parts. So what we're going to do is we're going to just notice this is going to be our f of x, our starting point that we want to decompose. But what we're going to need is we're also going to want an f of minus x value for this. So what we'll do is we'll just take our function, we'll plug in a minus x everywhere. So this is going to be cosecant minus x times cotangent minus x. And then to make it really clear, I'm going to break this into sines and cosines. So cosecant is 1 over sine minus x, and our cotangent is going to be cosine of minus x over sine of minus x. But I'll assume that we already know that cosine is an even function and sine is an odd function. So because cosine is an even function, we can kind of get rid of the minus there. And then because sine is an odd function, we can bring a minus out front here and do the same thing here. But because we're multiplying by minus on both these, we can cancel these. And so everything that was a minus just cancels out, and we can put this back as cosecant x times cotangent x. But again, this is just our f of x value. So just from this, you can actually see that our original function is even, but we're still going to go through this process and try to see what happens when we decompose it. Okay, so now we're ready to use our formula, and so our f of x value is going to be this cosecant of x, cotangent of x, and we're really just going to plug in. So we have our f of x value and our f of minus x value, which is the same thing. So here we have cosecant x, cotangent x, plus another copy, right? You can see I'm running out of space already here, but that's okay. And then for our odd part, I'll bring it down here. So this is going to be really similar. Cosecant x, cotangent x minus this time cosecant x, cotangent x. But now in this part, we're clearly subtracting the same thing. So this part here is going to 0. Then here we just have the same thing added. So we end up with 2 copies. That's pretty ugly too, but then I can take this 2 and cancel it with this 1/2. And so what we're left with is we have cosecant cotangent is the same thing as, of course, cosecant cotangent. But in this form, using this setup, we'll write it as a plus 0 here. So that this first part is an even function, which we already knew, which we already determined that this was an even function. So that makes sense. But for our odd part, we just got a 0. But that's actually okay, and that's going to happen sometimes with this. If you actually start with an even function, you're just going to get back an even function. If you start with an odd function, you're just going to get back an odd function plus 0. And we can actually look at a graph really quick. If this is our x and y axis, if our function's just 0, the graph is going to just look like a line like this. I'm writing it above 0, but this is supposed to look like our f of x equal to 0 line. And to check if this is even, all it needs to be is symmetric around the y-axis, which of course it is, right? So 0 is an even function. But now for it to be an odd function, we're going to want it to have origin symmetry, or if you rotate it 180 degrees, right? If we just rotate it all the way like this, we get back the same function. So it turns out the function 0 is actually an odd function and an even function. So in this case, this still makes sense. So that's it, just another quick example. We'll stop it there. Thanks so much for watching. Have a great day.